Okay. Back to our discussion once again. Hello. I hope you can hear me. Yeah. Back to our discussion once again. Last class we have discussed about work. We discussed about power. We will discuss today about energy. The different forms of energy. And how it is to be measured. Now, what is energy we understood? Energy is a capacity to do work. That means amount of work that can be done. Amount of capacity to do work, amount of work can be done, that can be measured with the help of energy. Now the energy possessed by a body can be in a state of rest or in a state of motion. So the two main forms of energy what we will discuss over here is kinetic energy and potential energy. We will discuss each one by one. We will discuss about kinetic energy and potential energy. Now, the total mechanical energy, when we are discussing every object we consider has got the mechanical energy. The total mechanical energy is sum of the kinetic energy plus the potential energy present in an object. So, mechanical energy is nothing else but the sum of the kinetic and the potential energy. Right? We will understand about kinetic energy, the different forms of kinetic energy. Then we will understand about potential energy, the different forms of potential energy and their directions. Let's come to it. Let's come to kinetic energy first. What will say about kinetic energy? Kinetic energy. The energy possessed by a body by virtue of its state of motion is called kinetic energy. The energy possessed by a body by virtue of its state of motion is called kinetic energy. Right? Got it? The energy possessed by a body by virtue of its state of motion is called kinetic energy. Now, that means I take a stone and throw it in a window pane. What is going to happen? The window pane is going to break. I take a stone and throw it in a window pane. What happens? The window pane breaks. Why did the window pane break? Because the stone had some energy. It was able to do some work. Because we understand energy is the capacity to do work. So whenever a moving object possesses some amount of energy, we call that one as kinetic energy. We come to the definition once again. The energy possessed by a body by virtue of its state of motion is called kinetic energy. Like a fast moving stone or anything has got kinetic energy. Let us understand the expression for kinetic energy. Expression for kinetic energy. Let's see. Now, to derive this one, we all studied this one. Kinetic energy equals to half mv square. How this one has come? We will discuss it today. How this one has come? Kinetic energy equals to half mv square. Okay. Once again to the definition, kinetic energy is the energy possessed by a moving body and is equal to the amount of work done when the moving body can perform, is equal to the amount of work done which the moving body can perform before coming to rest. That means a body is moving. How much amount of work it can do? That is the definition. Before it can come to rest, how much amount of work it can do? That is the amount of kinetic energy. Let us do the reaction in this way. Suppose a body got a body of mass m. Okay, I've got a body of mass m moving with a velocity of v. Clear? I've got a body of mass m moving with a velocity of v. Now, it is moving. I applied a force F, opposing force F to stop it. So, it is brought to rest by applying a constant opposing force F. Okay, so body of mass much? M. Initial velocity is what? How much? Initial velocity is V. Now I am applying what? Constant opposing force. How much? Is if I applied a constant opposing force. Now let A be the uniform retardation produced in the body. So whenever I am applying a constant opposing force, there will be a retardation. Let it be E. Okay. We have considered this one as A. If you are saying this one in terms of retardation, it can be minus also. Retardation A. Now it travels the distance. Now suppose the body is traveling, I apply the force, constant force F. It travels the distance S. Then it stops. So distance traveled equals to S. So it traveled a distance S before it comes to rest. Say this one once again. I've got a body M moving with the velocity of V. I applied a constant force, opposing force F. So the body traveled a distance S and it stopped. So it was facing a retardation E. So with these data we are going to find out what is the kinetic energy. Now we know retarding force F equals to m into a, that means mass into acceleration. Here mass into retardation. Let us consider this one. So retarding force that I have been applying is mass into acceleration or retardation. Now, kinetic energy, what is kinetic energy? Kinetic energy of moving body. Kinetic energy of the moving body is the work done by the retarding force is equals to work done by retarding force. So kinetic energy of the moving body will be equal to the work done by the retarding force to stop it. So what will we say? So kinetic energy K will be equal to work done. What is what? Force is the displacement. Force into displacement. My force is there. I want to find out the displacement. Right? Let's see. Now I will do the calculation. Okay. So here, instead of force, we can write as mass into acceleration. And now the displacement, we need to find out the displacement. Now what we can say? We can say V square equals to U square plus 2AS. V square equals to U square plus 2AS. Right? As A is my retardation, so it will be minus 2AS. Clear? So final velocity of the body is 0. Initial velocity was how much? V square equals to minus 2AS. So AS will be how much? V square by 2A. Let us replace it here. Right, got it? If K equals to F into S, F equals to MA, from here I got S. V square equals to U square minus 2S. So I got S equals to V square by 2A and replace it over here. So if I replace it over here, let us see what takes place. Can I have this? So make sure I'm doing it in the top. Okay? Let me have the whole thing. I will continue if you require it. So what we can say? Come back from here. So we can say kinetic energy equals to mass into acceleration equals to V square by 2A. A cancels. What do we get? Half m V square. So the kinetic energy of an object is measured with half m V square. Got it? of S, then it stops. So the retarding force applies is equals to m into A. The kinetic energy in the moving body is equals to work done by the retarding force. So work done means what? Force into displacement. Force I got m into A. Displacement viscous commands 2s. 0 equals to viscous commands 2s. S equals to viscous by 2a. I replace it over here. K equals to ma into viscous by 2a. A cancels K equals to half of v square. So this is the expression of finding out the kinetic energy of a moving body. Right? Got it? So we understood this is how we can find out the kinetic energy of a moving body. Now, I hope you practice it at home. Now, let us find out the relationship between kinetic energy of an object and momentum. I hope you remember what is momentum. Momentum is a product of mass into velocity. Momentum is a product of mass into velocity. P equals to m into v. I hope you remember it. See, from our deduction we understood how kinetic energy is measured. Kinetic energy is measured as half mv square. So kinetic energy is measured as half mv square. So we are going to find out relationship between kinetic energy and momentum. We are going to find out the relationship between kinetic energy and momentum. So we know kinetic energy equals to half mv square, whereas momentum equals to m into v. Right? M into v. So what we can write this one is, therefore, v will be how much? T by m. If I replace it over here, what do I get? Let's see. So kinetic energy equals to half m v square, that is half m p by m whole square, that comes to half m p square by m square. M cancel, half p square by m. Therefore, kinetic energy equals to p square by 2m. So kinetic energy equals to p square by 2m. Right? So we can also write momentum equals to square root of 2mp. These relations are very, very important to understand the relationship between kinetic energy and mass of the body if the momentum is constant. Very important relation, make sure you practice it. Kinetic energy equals to half mv square, momentum equals to product of mass into velocity, v equals to v by m. So replace it over here. So we got half m p square by, so half p square by m. So I'll write k equals to p square by 2m, p equals to square root of 2m. Okay? Got it? I hope you understood. So we understood the relationship between kinetic energy and momentum of our body. Now, there are different forms of kinetic energy. The different forms of kinetic energy which we should be knowing is translational kinetic energy, rotational kinetic energy, vibrational kinetic energy. Different forms are there. Now, what do we understand by translational kinetic energy? What do we understand by translational motion? Whenever an object is moving in straight line or straight path, we say it is in translational motion. So the energy, the kinetic energy possessed by an object when it is moving in a straight path is known as translational kinetic energy. So different forms we understood: translational kinetic energy, translational kinetic energy. Number 2, rotational. kinetic energy. Number 3, how much? Vibrational kinetic energy. All these things. So transitional means when an object is moving in a straight path. When an object is moving in a straight path, the energy possessed by the object is known as transitional kinetic energy. So like a car is moving in a straight path, a free falling body, object like this one, free falling body, this is called transitional kinetic energy. Now what we understand by rotational kinetic energy? If a body rotates about its axis, when a body rotates about its axis, the motion is said to be rotational kinetic energy. Like spinning of a top, right? Spinning of a top, the earth rotating on its axis, this is called rotational kinetic energy. Now vibrational kinetic energy, if a body moves to and fro about its mean position, if an object moves to and fro about its mean position, this is the mean position, a pendulum. I take a pendulum, it moves to and fro about its mean position. To and fro about its mean position, this is the mean position. This is the mean position, to and fro about its mean position. Then we can say it has got vibrational kinetic energy. Now, I take a wire and I pluck it. I take a wire and I pluck it. So what will happen? The wire is vibrating in this way, right? This is about vibrational kinetic energy. So these examples you should be knowing, make sure you practice it from your books about the different forms of energy, different forms of kinetic energy. Now it is not necessary that an object will possess only one type of energy. It can have multiple forms of kinetic energy possessed inside it, right? Depending on the state of motion, a moving object may possess either one or more than one type of energy, depending on the motion. Like if I say a rolling ball, a ball is rolling on a floor. If a ball is rolling on a floor, what we will say? It is moving straight, it has got transitional. It is rolling, it has got rotational kinetic energy, right? So different forms of energy it might possess. So we understood about kinetic energy and the different forms of